Dear students, there is a diagram here which shows different types of loading. You see, if this is the machine element and forces are acting like this, then this is under compression loading. If this is the machine component and the forces are pulling it apart like this, then it is tensile loading. If this is the machine component and one force is acting this side on the on the lower side, and the on the upper side it is acting to the right, then it will turn to cut it off like this, shear off. So this is a kind of shear loading. And if this is a machine component and on the top force is trying to twist it that way, and on the bottom side it is trying to twist the other way, then this is said to be under torsional loading. This is type example of torsion loading and representation of torsion loading. And here, if this is the machine component, if one force is here in the center and there are two forces on the other side trying to push it this way, then what happens is bending. So this is a kind of bending loading. Okay, you see here is a chart. Here is a graph uh, on an this is the y-axis, this is x-axis, and here we see a loading is going like this. This is you know that this is called sinusoidal wave. In the form of a sinusoidal wave it is going. That means at the point on the y-axis we are taking, on the x-axis we are taking time, on the y-axis we are taking the stress or the load. You see, at the point at the time 0 there is no load or no stress. You see, as the time is elapsing, the load is increasing to a certain extent, and it reaches a peak, and then when the time goes further it falls down to 0. And you see, on the positive side, if we take it as tension, on the negative side if it is compression, initially the load goes to a peak on the tension side and becomes 0, and then further if you proceed it comes to a peak, another peak on the compression side, and then it comes to 0. So from here to here this is one cycle, then this is the next cycle, that is again from 0 to the peak on the tension side, and again to 0, and again on the peak on the lower side, on the compression side to peak, and again to 0, like this kind of loading. You see, that means what, load is going to the compression tension side, then compression side, then tension side, like this is tension compression loading. This type of loading is called as cyclic loading. Here in this cycle we saw that it is half of the cycle is in the tension side, half of the cycle on the compression side. But it can be this way also. You see, it is initially having some tensile stress already. In that, again, in the tensile tension increased, then tension decreased. See, it never went below 0. That means it never went to the compression side. Again, it went up like this. See, it can be fully in the positive, that means on the tension side, it can be fully on the compression side, or it can be like this. So this type of loading is called as cyclic loading. And it can be, loading can be in this fashion also. Actually, in real life example, if some wind is blowing, if an earthquake is coming, it will not be so exactly sinusoidal loading. The loading can be plotted like this. Even if it is an earthquake, even much severe than this you will find. Here I found a plot that is uh, recorded during an earthquake in the internet. That loading will look like this. Okay, and now here we see different types of loading. These types are called as types of fatigue loading. So here you see this is called as the fully cyclic loading. This is the fully cyclic loading that we have seen, and uh, this is only on one side, so this is called as a repeated loading. And this one is this has come up to 0, that's why it is called repeated loading. This is didn't even touch, then therefore it is called as fluctuating loading. So in these things, what we see is, there is the top is called as sigma maximum, that is maximum stress. The minimum is the down is called as minimum, sigma minimum. You see, you can see here sigma minimum, sigma maximum, and this is the variation in the stress. This is called delta sigma. Okay, so the delta sigma is given here. Delta sigma is sigma maximum and sigma minimum, and this is called the stress range. Okay, and okay, we need not bother about alternating component. The mean component is sigma m, that is mean, is equal to sigma maximum plus sigma minimum by 2. Okay, and uh, let us come to this term called fatigue. You see, fatigue was discovered when several people noticed that the bridges and railroad components were cracking. You see, these are the bridges, they were cracking when subjected to repeated loading. Repeated loading means what? The load is not steady on the, when you plot on the XY graph. It is not steady, it is not a constant line. It is going up, down, up, down. That is called as a repeated loading. So, fatigue is caused by repeated application of stress to the metal. It is the failure of a material by fracture when subjected to a cyclic loading. These are all initiated in England, during initially when they were when they started using trains. This railroad bridge, this collapsed like this. It broke. Okay, and and what they have noticed is fatigue, this occurring suddenly without warning. There is very little plastic deformation associated with the fatigue fracture, so it is brittle like fracture. You see, actually you should understand what are types of fracture. See here, a fracture is shown here. This type of fracture is called as a brittle fracture. You see, this is a typical example of fatigue failure. The crack is developed from a small flaw or small crack, and then it reaches to the critical value. You see, this is the machine component. So there was initially a crack here. You see, and then you see the cross section will look like this. This was the material, solid intact material, and this was the crack. And because of cyclic loading, what is happening? It is opening its mouth, closing its mouth, opening, closing, opening, closing, opening, closing. Okay, and this crack propagates further like this inside, and finally it breaks into two like this. You see, if you see here, these marks, you can see these are called like actually in fatigue testing, these are called as beach marks, like on the sea beach, you see these marks. These are beach marks, or they are called as striations, and it will increase when only this much of material is remaining and it cannot withstand the load. It will suddenly break into two, and it becomes a catastrophic failure. You see, example of this is, suppose did you see how the axle of the trains are when there are wheels? two wheels, between those two wheels there is an axle. So axle, if no, it has its own weight. So suppose that axle is bent a little curved like this. Okay, I will see if I can find you some figure. Okay, now here you can see these axles, these rolls. You see what happens is when it is traveling, it will keep on rotating. So this now I'm little sagging it may be. Okay, so the upper fiber will be under compression, lower fiber will be on tension. And when it is rotating, the lower one comes up and upper one comes down. Okay, that way no, this type of loading is like a what we should say, it is like repeated loading. Okay, because of this, you see, if a train is traveling from Kashmir to Kanyakumari, so many thousands of kilometers, and how many times this will be rotating and going. Okay, and what happens is under those repeated loading means I showed you that chart. uh, in that repeated loading, what happens is these machine components, if there is a crack, suppose there is a crack somewhere here, and it slowly propagates, and I showed you just how a catastrophic failure it made, and it will break into two. Such a failure is uh, called as the so now what is fatigue? Fatigue is failure caused by cyclic stress or repeated loading. Fatigue can lead to failure even if stress is less than the critical stress. What is the critical stress? Critical stress means that stress at which it fails. What is the critical stress in case of brittle ductile materials? In case of ductile materials, it is the yield point stress. What is the critical stress in case of brittle materials? It is the ultimate stress. Okay, and what are those axles made of? Axles are not made of cast iron. Axles are made of steel. Steel is a ductile material. So what is the critical stress for that axle of the railroad? It is the yield point. So this fatigue can lead to failure even below the yield point. Okay, this is responsible for 90% of mechanical failures. So that's why this fatigue is so important. Now, talking about the stages of fatigue failure, say there are three stages. Initially, there is something called as crack initiation. Initiation means starting of crack initiation. So some crack comes. Why? It can be because of some stress concentration in one place, or some initially pre-existing defect somewhere, or because of the surface roughness or something. Somewhere the crack starts, and then crack propagation. Crack propagation means crack growing. Oscillating stress is repeatedly going up down like a sinusoidal wave. Crack grows and uh, stops growing. Crack grows, stops growing, then grows again stops growing. With crack growth due to tensile stresses. You see, as it you see, it is opening its mouth, closing its mouth, opening. You see, when it is in compression, it closes its mouth. When it is in tension, it opens its mouth. When it is compression, it closes its mouth. Opening, closing. That's why those striations that I showed you in that diagram, that beach marks, those are forming, opening, closing. Okay, like that crack propagates. Till when? Till that time when that cross section area can no more bear the load that is coming. Then there will be fracture, and this fracture is a sudden brittle like fracture when nobody can expect. Suddenly, if no, Think of it, if a railroad axle breaks in the middle when you're traveling in the train comes to a standstill. You see, this is how you can identify the fractures. You see, here they showed origin. This is the origin, that is where the crack was, and slowly it propagated. These are the beach marks you can see. Okay, marks, and finally it fractured. Okay, and here also it is shown. And now we come to another thing called as the endurance limit. Endurance limit is given as sigma E. Here in this they are showing as E. This is a stress level below which a material can be cycled for infinitely, can be cycled, can undergo or can experience infinite number of cycles without failure. That is the meaning of this endurance limit. Okay, now the question is, what is endurance limit? Endurance limit is defined as the maximum value of a completely reversed bending stress which a polished specimen can withstand without failure for infinite number of cycles, usually 10 to the power 7 cycles. It is known as endurance limit or fatigue limit. This is sigma suffix E. Here you should understand that it is not 107, it is 10 to the power 7, and this is sigma and its suffix E. This is the definition. You can write down and keep. Okay, and this is the endurance limit. You see, what is the definition saying? The endurance limit is defined as the maximum value of the completely reversed bending stress which a polished specimen, which a polished standard specimen can withstand without failure for infinite number of cycles, usually 10 to the power 7 cycles. 10 to the power 7 means how much? How much is 10 to the power 7? You see, 10 to the power 2 means 100. 10 to the power 3 means 1000. 10 to the power 4 means 10,000. 10 to the power 5 means 1 lakh. 10 to the power 6 means 10 lakhs. 10 to the power 7 means 1 crore. 1 crore cycles. Okay, see, I think if the train starts from Kanyakumari to Kashmir and Kashmir to Kanyakumari and again Kanyakumari to Kashmir, this is, this will be 3 times, 3 sides it goes. I think it will cross 10 to the power 7 cycles, 1 crore. Okay. Anyway, this is the definition of endurance limit. And this endurance limit, as we have talked before, it will be much below the yield point stress. Okay. And this is called as either endurance limit or fatigue limit. See, here they are talking about a polished standard specimen. That means in the laboratory to test, they use a polished standard specimen. I will show you how a polished specimen looks like. Yeah, if it is a rectangular cross section, then the polished specimen will look like this. And if it is a rod or something, the polished specimen will look like this. Here, threads are cut on the other side. It is not necessary that a thread should be there. Without threads also they can make it. And here is the entire apparatus, how fatigue testing is done. This is the motor, and this is the flexible coupling. This is a shaft. This is another shaft. There are roller supports here, and this is the specimen also is called a sample. Okay, and under that it is now subjected to some load. This is how a testing of the thing looks like. Okay, now coming to the SN diagram. S stands for stress. There are sigma. In the olden days, they were denoting stress with the symbol S, but nowadays we denote it with a sigma. So that's why this is called as SN diagram. Okay, SN diagram. You can see N means number of cycles, S means stress. So the fatigue strength is plotted on the y-axis, and number of cycles are plotted on the x-axis. And here you see this is 10, this is 10 to the power 1. Sorry, it's not 10, 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, 10 to the power 4, 10 to the power 5, 10 to the power 6, 10 to the power 7. Okay, and on this side it is fatigue strength. On this side, number of cycles are plotted like this. Normally what graph you use, it is called as log graph, log table, or what is it called as? Sorry, graph table, graph paper it is called. Okay, but on one side, if you are using like this, you see 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, that means this is 1, this is 100, 1000, 10,000, and 1 lakh, 10 lakhs, 1 lakh, oh sorry, this is 1000, this is 10,000, this is 1 lakh, this is 10 lakhs and 1 crore. You see, if you are plotting like this is called as semi-log. Only one axis it is taken, like this. The other is normal thing. So that is why it's called semi-log paper. And this side on x-axis also you take log, and y-axis also if you take it is called as log paper. By and by you will come to know. Okay, in when you study further up in engineering colleges and all, you will use such papers, log, semi-log. Okay, okay. Now you see this is SUT. SUT means ultimate tensile stress, and this is the SE. That is the endurance limit. Okay, and initially up to 100 cycles, it is called low cycle fatigue, and up it is called as high cycle fatigue. Okay, okay, this plot of fatigue strength, sigma f or SF versus stress cycles n, capital N, on log paper, this plot is known as the SN diagram. For the ferrite materials like steel, this graph becomes horizontal, maybe around 10 to the power 6 cycles. That means around 10 lakh cycles, indicating that fatigue failure will not occur below this stress. That means what? This is your ultimate tensile stress, and this is your yield point endurance strength. So if you are loading in such a way that the stress will not pass this, that means your cross section should be big. If the cross section is big, stress will be less. If you are reducing the cross section, stress will go up. If you keep like this, it will, you see it will never meet that chart. This chart that is going is like this. Okay, and if you keep your load in such a way that the stress is less, and it will not failure for infinite number of cycles. Okay, this stress is known as the endurance limit. This is, when it is becoming flat, this is becoming endurance limit. Okay, okay, this curve which is called as SN curve, this is sometimes asked for theory for 3-4 marks. So we have studied this also. Okay, today we'll stop here.